Okay, so we need to quantify these concentrations of solutes in solvents. So I'm going to talk about not only molarity, but other ways that we can quantify the amount of stuff that is dissolved. So a lot of the times in everyday life, we use percentages. This is especially used in pharmaceuticals and things like that when you're trying to dissolve a specific amount of something. Or if you buy like a certain percentage of hydrogen peroxide solution, something like that. So percentages are actually used a lot. And we can do 3 different types of percentages. It can either be a mass over mass percentage, a volume per volume percentage, or a mass per volume percentage. So you kind of got to watch whatever the unit says. If it says MM or MV or VV, I do believe active uses a W for weight instead of mass. But it's the same thing. And that's just telling you what the units are going to be. A percentage is always just a part per a whole. So a mass for mass percentage would be the mass of your solute over the mass of the whole thing, the whole solution. Volume would be volume of solute over the volume of the whole solution. And mass per volume would be mass of solute per the volume of the whole solution. So it's just part per whole times 100 for all of those. Those are pretty easy to calculate, but we will be using them for conversions and measurements as well. One that we use a lot in environmental purposes is parts per million or parts per billion. And that's like of all of the particles, 1 in 10 to the 6 particles is a solute, or 1 in 10 to the 9th would be parts per billion. We won't be doing any calculations with these, but I just wanted to introduce them to you because those are other ways that we measure concentrations of particles, mainly very, very low concentrations, like things in the atmosphere. We will be using mole fractions, which we talked about back in the gas laws unit. Mole fraction is the mole part that you're looking for. So the moles of A or B or C or whatever over the total moles, right? We use those with partial pressures. This is actually also equal to partial pressures. We've talked about molarity. Molarity is moles of solute per liter of solution. And finally, a new one that you really have to focus on the definition of this one is called molality. So molarity is capital M, and we say something is whatever molar. That means molarity. Molality, which is 2 L's, is a lowercase m. And this has to do with moles as well, but it's moles of solute per kilograms of solvent. Notice this is the only one that on the bottom, it's not the total, it's not the solution, it's just the solvent. So not the whole thing, it's the moles part of your solute versus your kilograms of your solvent. So moles of NaCl per kilograms of water, for an example. This one is going to be very important when we are figuring out what are called colligative properties. So we will be using this. So this is probably a new one, and it is on your equation sheet, but molality is going to be important. So you need to read carefully your problems if we're talking about molality or molarity. Okay, so example number 2 and 3, I have the work up here, and then I am going to have you try to do the next couple by yourself. But example number 2 says the solution contains 25 grams of NaCl dissolved, so that means that's my solute, in 100 grams of water. Okay, so that's my solvent. What is the mass percent? So it's the percent of your solute over the mass of your solute over the mass of the whole thing of the solution. So it would be 25 over 125 times 100, which is 20%. And I put that period there because it has 2 significant figures, because this number has 2 significant figures. Now, remember, everything except molality is the part for the whole thing. Okay, so example number 3, what volume of solution is required to deliver 45 grams of NaCl if a 5% grams per milliliter NaCl solution is used? So this is like a problem solving one. I'm not just asking you to calculate the concentration. I'm giving you the concentration. So it's 5% in, this would be a mass per volume percentage, NaCl. So I want to know the volume part. I want to know how much if I want to have 45 grams of sodium chloride. So this is a very good example of a calculation that would be needed for like an IV, right? How many milliliters do I have to give this person to make sure that they get 45 grams of whatever it is? Now, 45 is a lot, but this is that type of calculation. So I wrote down what I know. I wrote down I need 45 grams of NaCl, so that's a mass. I need to know the volume. I know it's 5% grams per milliliter. Now, percentages, all of those are times 100, right? Anytime you do a percentage, it's times 100. This one would be times 100. This would be times 100. So you want to divide by 100 first. So instead of using 5%, use 0.0500. And that had 3 sig figs. That's why I kept 3. So it means it's 0.0500 grams per milliliter. So then you can just plug in the grams here that I need and then solve for the milliliters. So I need 900 milliliters in order to deliver 45.0 grams. Okay, now example number 4, oh, it looks like I also have example number 4 on here, and then I'll have you do the next couple by yourself. But this one has to do with molality. Remember, molality is the only one that is not part per whole, it is part per part. Okay, so what is the molality of a solution that contains 60 grams of glucose in 500 I put that there so it has 3 sig figs milliliters of water? Assume the density of water is 1 gram per milliliter. Now I did give you this for a purpose and I will show you why. So I need molality. Molality, lowercase m, is moles of solute per kilograms of solvent. Okay, so what do I have? Well, I have 60 grams of glucose and I know that's my solute. And I have 500 milliliters of water, which is my solvent. So I need to determine both parts. Well, this is in grams and I need moles. So all I did is convert my glucose molar mass here to moles. So it's this many moles of glucose. So that's going to go right up here in my moles. And then I need kilograms of solvent. So I have 500 milliliters of water. I need to get from milliliters to kilograms. Okay, so what I did is I used the density. This is why I gave it to you. It's 1 gram per milliliter. So that would give me to grams. And then I just converted that to kilograms. So anytime I give you the density, you're probably going to need it to get from volume to mass or mass to volume. Okay. And we did that in the very first unit. So then it's 0.500 kilograms. So I could plug that into my kilograms of solvent. Do my math, I get 0.666. So let's put an extra 1 on there, 6 molality. Okay, so try example number 5 and 6 and 7. Now 5, 6, and 7 are very application based. So try to do these, see if you can do the conversions, and then I will quickly walk through kind of the answers and how I got there. Now, as I said with these problems, these are more problem solving type questions or conversions. And I like to do all of these as dimensional analysis because again, if your units work out, you're going to get the right answer. So it says, what is the molarity? So I just wrote down equation for molarity of a 10% mass per volume or grams per milliliter glucose solution. Now you did have to know what glucose is. Its molar mass is here. 10% mass per volume solution means, remember, divide by 100. So it's 0.100 grams per milliliter. So I started with that 0.100 grams per milliliter. I just put the 1 down here. It means it's 0.100 grams of glucose or solute per 1 milliliter of your solution. And so really all I want to do is convert this unit into this unit. So I need to get grams into moles and I need to get milliliters into liters. Doesn't really matter what order you do it in. So I need to get grams into moles. So I need molar mass. That gives me to moles. And then I need to get milliliters to liters. So I do that conversion and I end up with this as my answer. So it's really just a conversion. Watch your units. It's like, well, what unit are you starting with? In this case, it is probably going to be a this per this thing. So you'll have 1 unit on top and 1 unit on bottom. And then you just need to convert them into what you need them to be. Same thing with example number 6. You do have to know that sulfuric acid is H2SO4. It's sold at 98% mass per mass. Remember, that would be grams of solute per grams of solution or part per whole. So it's mostly sulfuric acid, only a little bit of water, only 2% water. So that means it's 0.98 grams of sulfuric acid per every 1 gram of solution, part per whole. Now I want to get it to, it says, what is the molarity? I want to get it to moles per liter. And I did give you the density. Now, when I'm giving you the density in these types of questions, when we have concentrations, you're going to be using the density to convert into correct units. So I need to get from grams of sulfuric acid per grams of solution to moles of sulfuric acid per liter of solution. So I went ahead and converted sulfuric acid to moles. That's an easy one. Now that would be moles per grams. I need to get it to liters. And the only way to do that is to first convert grams into milliliters. So 1.8 grams of solution per 1 milliliter. That would give me milliliters. And then I need to go to liters. So actually, let me add that in here. There we go. So then I convert it into liters, and this would give me moles per liter. So check your units, you get it to the right unit, you're good. So sulfuric acid at 98% is an 18 molar solution, which is a little really high. All right, example number 7 is more kind of like an extra credit question because I'm having you do multiple things and I'm having you go from a part per whole unit to a part per part unit because I want to do the molality. So all I gave you was the hydrogen peroxide. Now you do have to know hydrogen peroxide is H2O2. I would tell you that if this were the exam. And I've got a 30% mass per mass solution. Now, this is a really strong hydrogen peroxide solution. It would burn you. The stuff you have at home is actually like 3% hydrogen peroxide. So this is what is the molality. So I have 0.3%, or sorry, 30%, which is 0.3. That means there's 0.3 grams of solute per 1 gram of solution. So I started here with that. Okay, now I need to get from grams of solute per gram of solution to moles of solute per kilogram of solvent. So I have to do a little thinking here, okay? So I started with this unit. Now I went ahead and converted this into moles because I just need it to be moles of solute instead of grams. So I used the molar mass of hydrogen peroxide. And then I need to get from grams of solution to kilograms of solvent. So to get rid of my grams of solution, I put 1 gram of solution. So how much of my solvent is in every 1 gram of solution? Well, I know based on my percentage that 30% or 0.3 grams for a 1 gram solution is H2O2. So the rest must be solvent. So 0.7 grams must be my solvent. So I wrote that down here. If 0.3 grams are H2O2, then 0.7 grams are water. So there's actually 0.7 grams of water or solvent per 1 gram of solution. So this would actually get me 2 grams of water. Now I do want not grams of water, but I want kilograms. So then I converted grams to kilograms and I get 12.6 molality. I also then wanted you to do mole fraction. So that's mole of your part or H2O2 per moles of your total. So I converted my 0.3 grams of hydrogen peroxide to moles, converted my water part, that 0.7 grams to moles as well, and found that it's 0.958 for the mole fraction as well. So again, this is more like an extra credit type question. You really had to think about where those numbers are coming from and be careful with the molality unit.